Hi dear students, welcome back to e-learning classes. Myself Santosh J. Today I am going to teach you the continued part of additive manufacturing process. The today topic is that additive manufacturing process chain. As we can see on the slide, here we have 8 images on the slide. The first image is shows that 3D model, and second image is shows that STL file conversion, and similarly the third image is indicate that file transfer to machine. However, the fourth image is indicate that machine setup, and similarly the fifth one is indicating that built, and similarly the sixth one is built removal. As we can see in the seventh image, we have a cup teacup type of produced 3D object that's need for the post processing. And as we can see, the last image is a produced 3D object for the particular application. And move on to the next slide. Additive manufacturing process chain, which includes there are 8 steps. As we can see, the first step is conceptualization and CAD. In this step, the 3D models are designed based on the conceptualization by using convenient software. Similarly, the step 2 is conversion to STL file. In this step or in this stage, the created 3D model is saved into the STL file. STL file, which means, as I told before, the standard triangular language. Now, STL file gives the geometrical information about 3D models. The given geometrical information are matched with the those 3D models. There is no error from the STL file, which means the chosen STL file is correct, then is known as STL file conversion. Coming to the step 3, transfer and manipulation of STL file. Once the chosen STL file is correct, which is transferred into the additive manufacturing machine, otherwise chosen file is incorrect, then it need to be manipulated as per the requirements. And move on to the step 4, machine setup, which indicates once the STL file reaches to the additive manufacturing machine, now the machine is need to be set, which means the required machines and equipments, machine parameters are need to be arranged. As we can see the step 5, the material and support structure built. In this stage, to develop the building aspects such as raw materials from the 3D object, platform, and other supporting materials and structures. Coming to the sixth step, part removal and clean, which includes the part removal and cleanup after forming a 3D object. This process is need to remove the excess raw materials, supporting structure materials, platform, and other arrangements. Meanwhile, to clean up all the building arrangements. And next move on to the step 7, so that is called post processing of am parts. The produced 3D object is required to some post process operation such as finishing, grinding, and polishing required for the demand. Next, coming to the last step, application of am parts. The 3D products are ready for the end users for the particular application. I hope that this session was useful. We will stop now and I will continue to the next session. Thank you. Okay, dear students, let's begin the session. The today's session is classification of additive manufacturing process. There are 6 classification in the additive manufacturing process. Number 1, liquid polymer resin system. Number 2, direct metal laser sintering. Number 3, selective laser sintering. Number 4, liquid molten material system. As we can see, the fifth one is fuse deposition method. The last one is solid metal system. Okay, dear students, move on to the next slide. As shown in the figure, which indicates that liquid polymer resin system, which consisting of vat or tank at the below, which is filled with a liquid polymer, whereas at the top there is a laser focusing unit. Inside this vat or tank there is a substrate that attached to the moving piston, as we can see. Then it is moves down with the help of the piston, which means the amount of liquid is moves up. Then it is flowing over the substrate and it is exposed to the laser beam. Now the laser beam is focus the resin, which means process of curing is done and layer 1 is built. Again this process will repeat same, the layer 2 will form. Then that layer 2 that has to bond with the layer 1, this will continue till the formation of 3D object. We hope you understand how the 3D object is formed by this polymer resin system or technique. Okay, move on to the next step or next method. This figure indicates that direct metal laser sintering, DMLS, direct metal laser sintering system. In this method, the powder form of the particles are used to create the 3D object. As we can see, there is a feeder mechanism which continuously feed the particles, which are then fed on the substrate. Now the roller is rolled on the surface, in which to maintain the uniform thickness at the top, the laser nozzle is provided, which traces the particles and they get fused to create a required design. Subsequently, the feeder is feed the new particle materials, then they are fed onto the design cavity to develop the first layer as per the design consideration. Now the platform is moved down and the process will repeat till the formation of 3D object. I hope you understand how the DMLS process works to produce the 3D components. Dear student, as shown in this figure, this is a selective laser sintering system. Now let me to clear how it works. Dear student, see here, there are two powder beds are there. This is the powder bed 1, this is the powder bed 2, which is called powder delivery system. This is called powder fabrication system. Now this powder delivery system bed is moves up and down with the help of the below piston, because this powder bed is attached to this piston, and here also this powder bed is also attached with the at the bottom piston. Now this piston is moves to and fro motion or downward and forward direction. So once the piston is moves down, in this case moves down, the raw material is moves up. Here there are the roller supporters are there. These rollers are carry the raw material and fed into the bed 2, then which are fed into the bed 2. Now at the top of this bed 2 there is a scanner is there. This scanner is scan these raw materials, and due to the hot laser these materials are get fused and to create the required design and shape. Once the design shape which we are getting, again the powder bed 1 is supply the powder materials, then the powder materials are covered by that cavity, whichever the cavity is created by the scanning, that is covered by the raw materials. Now that cavity is filled by this powder raw materials. After cavity is filled completely and successfully, this piston is moves down. Once this piston is moves down, which means the certain thickness of layer is already formed, so which is called as layer 1 is formed. And again this piston is moves up, again amount of raw material comes up. These two rollers are carry the raw materials and fed into the bed 2. Again the laser beam is chases the raw materials, again the cavity will be formed as per the required shape and size. Again the raw material is covered by this cavity, again this bed is moves down, the second layer is formed over the first layer. So this process will continue till the 3D object is formed, required 3D object is formed. I hope you understand, dear students, how it works. This is called selective laser sintering system. Okay, dear students, as shown in the figure, this is the FDM process. Fused deposited materials. As shown in the figure, this is the big ruler. It's called as a spool, which means the bundle of fiber materials are available here. These bundle of fiber materials are continuously fed into the temperature control unit, then they are finally passed into the nozzle, then they are deposited into the substrate, deposited upon the substrate. These fibers are continuously fed into the temperature units by means of these two rollers. Once these two rollers are moving clockwise direction, which means the fiber is continuously pulled by the spool and then fed into the temperature control unit. Once it is fed into the temperature control unit, or once it is passes to the temperature control unit, this temperature control unit is maintaining the temperature of these fibers. The temperature maintained fibers are coming to the nozzle. The nozzle throat is set depends upon the thickness which you want, or which customer depends. Now the temperature controlled fused fibers are come out of the nozzle, then they are deposited over the substrate. This process is continuous, which means the fiber is continuously fed into the temperature control unit, then that passes, or then that come out of the nozzle till the 3D object is built at the bottom. Hope you understand how it works. Very simple technique which is used in Toyota company most commonly. Okay, now I will stop. We will continue the lepto topic in the next session. Thank you. Bye, Santosh Vijay.